Hello and welcome. In last video, we have seen this example. Here the problem was class cast exception. The problem occurred in this line, but the real culprit was this line, IOB equals to STROB. Okay, so we have seen here that IOB is IOB is a reference variable pointing to an object containing integer, and STROB is a reference variable pointing to an object containing a string. But when IOB equals to STROB, then the reference of STROB is copied to IOB, and IOB is now not pointing here, but it is now referencing this. And when I get OB, my object, then what will happen? It will return a string, and this string is now typecasted into integer in the next line, and therefore I am getting my error. This is because Java has no way of knowing that what IOB is referencing to is integer or string, or what STROB is referencing to is an integer or a string. Fine. Since both of them are non-gen objects, this line is syntactically valid, but it is semantically wrong. Therefore, we are getting a class cast exception. Now let's convert this non-gen class into generic class. Okay, now we will code for generics. For example, I change its name to gen. Okay, and here what I will do, I will simply write a type parameter. So what T is a type parameter. T is a type parameter. It will contain the type that I will pass while creating its object. While I am creating the class object, I will pass a type that can be an integer, that can be a double also, that can be a float, that can be a string. Okay, whatever type I pass, it will contain that. So this is nothing but a placeholder. This is nothing but a placeholder. Whenever a type parameter is declared, it is specified within angle brackets. Because generics uses a type parameter, gen is a generic class. So why gen uses a type parameter, it is a generic class. Okay, also known as parameterized type. Also known as parameterized type. Now T will be used to declare an object reference variable of type T. Okay. Now OB is a reference variable of type T. As explained, T is a placeholder for the actual type that will be specified when an object is created. Thus, OB will be an object of the type passed to T. If I pass an integer, OB will be an object of a type integer. Okay. If I passed a string, then it will be a reference variable for a string. Fine. Now let's consider its constructor. Okay. The name of the class is gener, and here we will have TO. Now O is a reference variable for a type T. Okay, and OB is equal to O will do the same work as it is done in the last video when I have explained. This means that reference is copied from O to OB. Okay, then here the return type now will be T. Here the return type now will be T, and I will get my return OB. Okay, because OB is also of a type T, it is type compatible with the return type specified by the get OB. Okay, so till now what we have done, whatever I pass from my gen class, let it be integer, double, string, whatever, T is acting as a placeholder. T is acting as a placeholder. Okay, they will replace T everywhere. So if I pass an integer, it will become an integer. It will also become an integer in backend. It will also become an integer. It will also become an integer. Fine. Now let's update the main class. Now the general class object IOB equals to new. But now what I have to do? I have to pass the angular brackets integer. So when integer is passed in the angular brackets, now T will become integer. Now it will know that the object is of integer type. So the reference variable is IOB integer object. Fine. New gener. Okay, fine. So now this will work. So what I have passed, I have created an object. And I have told that it is containing a type integer. It is containing type integer. Okay. Now the first thing you will notice, this becomes obsolete. Now I do not have to use typecasting, not manual casting. Now autoboxing and unboxing will occur. Therefore I have told you before watching generics, watch autoboxing and unboxing. Okay, now autoboxing will occur and unboxing will occur. When I pass 88, it will be autoboxed from an integer, small int, to capital integer. Okay, it will be autoboxed from int to class integer. Fine. Please watch the videos of autoboxing and unboxing to grasp this concept. Fine. So int to integer. Then when the value is returned here, it will be returned as an object. So we will be converting from an object of integer class to primitive type int. So this is known as unboxing. So we have autoboxing, unboxing, and the value will be stored in v and system.out.println v. No issues. So we have covered integer. Now let's see for string. Now same what we have done for integer, we will do for string. The class name, okay, and here we will pass string, string string, okay, the class name. So now it will be passed. Now again you can see we do not need here what you say a string, manual casting, okay, because it will automatically cast it. Now the object that is written is of string type, so it will be stored in a string variable and it will be printed. No issues. Now you can see we can see a compile time error. We can see a compile time error now. Okay, this was the main problem that is solved by generics. Now we can, on the compile time, when a programmer is typing, he knows that whether I am writing it correctly or wrong. Okay, it is now a syntactic error because it is, see the error, incompatible types required java.lang.integer but found java.lang.string. Because it is an integer, so it should store only integer values, but we are passing a reference of a string, therefore it is saying that it is wrong. It is a compile time error, so we have to delete it. So the error of class cast exception is solved with the use of generics. Now as you can see, it is a generic class. Gener is a generic class. I am passing an integer, it is working. I am passing a string, it is working. I can also pass my double, it will work. I can also pass float, you can do it. I urge you to do it. Just write this code down and do it for integer, for double, for float, for byte, whatever you want. Okay, just try and code it. So few points to remember. T is a type parameter. When I am passing integer here, it is known as type argument. Okay, known as type argument. This effectively creates a version of gener in which all references to T are translated into references of integer. Fine. The next important point is it will not work for primitive types. Okay, so we have int. This is a primitive. It will not work for primitive. It will only work for classes. Okay, we have to pass a wrapper class integer. Okay, we have to pass this class. It will not work for primitive data types. Fine. It will only work for reference type. In this video, we will see bounded types. In the preceding examples, the type parameters could be replaced by any class type. Okay, so we have seen that when we write gen class and pass a t here, so this can be replaced by any type. Okay, by integer also, that is by numeric types also, and string types also. Okay, by any class type. This is fine for many purposes, but sometimes it is useful to limit the types. Okay, sometimes it is useful that only numeric type should be allowed. Sometimes it is useful that only string type should be allowed. Okay, so how we will do this? So here comes the concept of bounded types. The problem statement is create a generic class that contains a method that prints the type that was passed. Okay, and the foundation is the type that is passed should be only integer, float, and double. So the numeric type should be passed. Okay. So if I pass integers, it should print java.lang.integers. Okay, because integers are stored in java.lang, therefore it should print java.lang.integer. If I pass float, so it should print java.lang.float. Okay, if I pass double, it should print java.lang.double, and I should not be able to pass string. So I hope you understood the program. I hope you understood what we have to do. Now let's code it. So let's code it now. So we will create a generic class, okay, a class gen that takes a type parameter t. So in the last example also I have explained that t is nothing but a placeholder. Okay, whatever I pass here from the main class, whether it be integer, float, or double, that will replace t in our program. Okay, t and a, just a single variable, a reference variable of type t. Okay, a simple constructor t and a simple constructor t and a to initialize the value of a. Okay, so this dot a equals to a, fine, and a method that returns nothing but it prints the type, print type. Okay, so let's see how you will print type. System dot out dot println, and I will print my type. Fine. So but before doing that, what I have to do, I have to bound it. Okay, t should take only numeric types, not string types. So how will I bound it? Now we need a way to ensure that only numeric type parameters are passed. Okay, this is accomplished through the use of extend clause. Through the use of extend clause. So this is how we write extend. T extend a superclass. T extend a superclass. This specifies that T can be replaced by superclass or subclasses of superclass. Okay, so T can only be replaced by the superclass that we write here or the subclasses of that superclass. Now let's see what is the superclass that we will use to bound T to only accept numeric types. Fine. So the superclass that we will use is number. That is number.java. Okay, why we will use number? Because subclasses of number are nothing but numeric types. We have integer class, we have float class in here, we have double in here, we also have big integer in here, and all the numeric types are the subclasses of the superclass number. Okay, so we will use number as my superclass. So we will use extends t extends number. Okay, now t will extend number. So what it will specify, it will define an inclusive upper limit. So t has an upper limit of this number. So all the subclasses in numbers and the superclass itself are only the accepted types in t now. Fine, so we have bounded t with the help of number. So what we will print here, we will simply print a dot get class dot get name. Okay, so this line, the get class and get name function, will simply give me the class name. Okay, now let's move and write in our main function. So in the main code, what we will write, we will create a we will create simply an object. Okay, so gen, and we will pass suppose integers first. So we will pass integer gen equal to, this is our reference variable. Now we will create our object new gen, and we will pass suppose 6. Fine, there is no need to pass 6, we will pass suppose 6. Okay, now I will call using my reference variable gen the function print type. Okay, now let's see what it will print. So as you can see, I passed integer and the output is java.lang.integer. So number is a superclass which with a subclass of integer. Okay, so integer is a subclass of this superclass number, so it is accepted. So we have no issue till now. Simply same thing I can do for gen double. Okay, we will pass now a double, and here again gen1 equals to new gen, and I will pass a double value 6.7 for example. Okay, and then I will call from gen1 simply print type dot print type, and when I run it, now I will get java.lang.integer for this print type and java.lang.double for this print type. Okay, so I don't have to write a different variable, a different constructor, and a different what you say method for integer differently and double differently. This is generic. So as you can see, java.lang.integer and java.lang.double. Okay, now same thing you can do for float. Please write it down on your code. But what if I try to send string? So see, it shows me an error that type parameter java.lang.string is not within its bound. Fine, it is not within its bound. See the error, not within its bound. So it says at a compile time only that it is not within the bound, it is out of bound. So because we have bounded the t with number, we have bounded the t with number. So this was bounded type. Also, you see with the use of generics, these errors are shown where on the compile time only, not at the runtime. So this is also one of the most important use of generics. Okay, the most important part of generics is we do not go, the errors do not go to the runtime, but they are solved at the compile time only. So generics will be widely used in the next concepts of collections. Okay, they are widely used in collections. That is the main implementation of generics. Collections use generics very often. Okay, and similarly as we have seen, so these are generic classes. We can also have generic method, generic interfaces. We will see a lot of generic example when we will go to the collection videos. Fine. So this is how you bound a generic class. Okay, you can also bound a generic method. Fine, no issue in that. Fine, so this was bounded types. Now we know how to make a class generic. Okay, so we have seen what was the problem if the class was not generic. Fine, we have a class cast exception. To remove that exception, now we have Java introduced the concept of generics. So the 2 points which were important was type safety, so it is not type safe. Also the casting is also no manual casting is done now. All auto boxing and boxing All the casting is done with the help of auto boxing and unboxing that Java does by itself automatically. Fine. So this was generics. Thank you.